Welcome to Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we'll also be answering the question, how do you solve rational equations? Notice there's a 2 there, meaning this is the second example in this video series. So the first thing we want to do, I'll just remind you of the steps, is to list the restrictions because the denominator cannot be equal to 0. Then we're going to clear all the fractions out by multiplying each and every term by the LCD. Finally, we'll solve whatever resulting equation we have, and then we'll either reject or check and accept any solutions that show up. Let's take a look at our example. All right, so we have x plus 6 over x equals -5. Now the first thing I'm going to do is make this a little easier on the eyes and come back and show the denominators of 1 under the x and 1 under the -5, just to have everything looking uniform here before we get started. So the first step in this process is to note any restrictions on the variable that we have. Well, we have 2 denominators that are 1. And so 1 does not equal 0. We don't even have to worry about either of those. However, x could be equal to 0 in this case, so we need to note that x cannot be equal to 0 because if we plugged 0 into that second term on the left-hand side, that would have 0 in our denominator, creating an undefined situation for us. Okay, so let's go ahead and move on to the second step, which is to clear these fractions out. To do that, we need to note what the LCD is, and the LCD is quite simple for this particular problem. I have all my denominators written over here, and the next step is just to prime factorize each of these. And that just has a factor of 1. X is simply x, and 1 is simply 1. So our LCD is 1 times x, which is just x. All right, so I'm just going to rewrite my original equation, and I'm going to leave room to come back and multiply every term by the LCD. And the LCD is x, so I just want to multiply each term by x. Let me remind you, this is happening in the numerator. And we do this so that we can come back and say, well, anything divided by itself is 1. Our 2 other denominators are 1, so they'll just go away and be understood to be there. X times x leaves x squared. We don't have anything left to multiply the 6 with, so it's just plus 6 equals -5x. So actually, this has morphed into a quadratic equation, and you should remember from earlier studies in the textbook that to solve quadratic equations, if you can factor them and use the zero product property, that's how you should solve it. So to do that, we have to first have our equation equal to 0, so I'm just going to add 5x to both sides to give x squared plus 5x plus 6 equals 0. We factor the left-hand side there, which gives x plus 3 times x plus 2. If you don't remember how I just factored that, you can go back and watch the video tutorial on factoring trinomials whose leading coefficient is 1 to help you understand how I just did that. And now we apply the zero product principle by setting each of the factors equal to 0 and solve. So I'll subtract 3 here, and I get x is -3. And I subtract 2 with this one, and I get x is -2. So I have 2 potential solutions here of -3 and -2. The first thing I want to do is check them against my restricted values for the variable. Well, neither of those values are 0, so at this point they're legal, and we just need to check them in the original equation to make sure that they give a true statement. So the first one I'll check is x is -3. Once again, you always go back to the original equation, so -3 plus 6 over -3 should equal out to -5 if we have a solution here. So -3 plus, well, 6 divided by -3 is -2. And sure enough, when I combine -3 and -2, I get -5 on both sides, giving a true statement. Now I also need to check -2. So I'm just going to plug it into the original equation just like I did with -3. And simplify down each side. So I have -2 plus -3 is -5, and -5 equals -5. Check. So you can write this one of two ways. You can say x is equal to -3 and -2, or you can use set notation and show that this can either be -3 or -2. Either of these are acceptable. You may want to check with your instructor to see which they prefer you to answer in. So I hope that this has been helpful to take it one step further and actually end up solving a quadratic in this rational equation. So it's possible to have 1, 2, 10, however many solutions show up. And in this particular one, we had 2 solutions. So just remember your steps. Make sure that you check your restrictions. You don't want to call something a solution that's going to create 0 in your denominator. And then next you clear all the fractions out by multiplying by the LCD and then solve the resulting equation. I hope that this has been helpful. If you have any other questions about this topic, please contact your Highlands instructor. Thank you.